Hi, everyone. I'm Doug Black at Inside HPC. And today, on behalf of Dell Technologies, we're talking with Rob Rowsell. He is engineering manager at Wirth Research. Wirth is a UK company specializing in computational fluid dynamics directed at energy efficiency in building design. Rob, welcome.
Thank you very much for having me.
Okay, so tell us about Wirth Research. Interesting company, interesting corporate history. As I understand it, the company began using CFD for Formula One race car design, but moved into green building design. Is that basically the evolution?
Basically, yeah. So we started in 2004 to primarily help Honda in the IndyCar Championship in the States, focusing on aerodynamics and chassis design to help them improve the performance of the cars their teams were running. Back then, the main aerodynamic tool was wind tunnel testing, and I joined the company in late 2004 to start the CFD department because it was just getting to the point where it could start yielding useful results. And since then, I drove the CFD capability from one computer in the corner of my bedroom to thousands of cores over the next subsequent decade. And we expanded from doing Indy cars to Le Mans racing, both in America and Europe, and Formula One as well. So then around 2010, we started diversifying outside of motorsport, where we had taken the various technologies we'd developed and refined, evolving at the coalface of motorsport. And we started taking those technologies and pointing them at other industries that hadn't had that evolution of refining the technologies. And we realized that we could use engineering technologies focused at making a car go very fast for a fixed amount of fuel. And we could make other things perform as well, but for less fuel or less energy. So one of the first industries we looked at was haulage, because they burn a lot of fuel moving trucks around. So we developed an aerodynamic kit to reduce fuel consumption of UK hauliers. Then we started talking to supermarkets initially about their lorries, but they said, well, actually, one of our main issues is refrigeration. So we got into developing retrofit kits to help keep product temperature in open-fronted refrigerators at the target temperature, but using a lot less electricity to keep those fridges cool. And in the background, we'd also started working with architects to make their buildings more aerodynamically efficient. And then those two streams combined, and we started helping supermarkets make supermarket aisles more comfortable and more efficient. And so on.
Okay, well, tell us about, on the software side, if you would, just as a point of interest, some of the CFD packages you're using.
So over our history, we've used ANSYS Fluent as one of our main CFD solvers, and also OpenFOAM. So we're using a lot more OpenFOAM these days. So the two main solvers we use are Fluent and OpenFOAM. Other packages we use to support that process on the meshing side would be things like ANSA and from Beta CAE and Helix. And then we post-process, make the visuals, turn the data into engaging pictures and informative, intuitive visuals using packages like Nsight and PowerView.
Okay, and on the hardware side, I understand the company has carried its energy efficiency ethic over to your infrastructure, and that you've teamed up with Verne Global, which of course is
Mhm.
geothermal-powered colo based in Iceland.
Yeah.
When did that happen, and how is it working out?
So through 2020, it was on our to-do list to start looking at reviewing all our infrastructure anyway, because it was up for renewal. Then when the pandemic hit and we had to move people to remote working, we realized that people could remote work and do the type of job we were doing. And we didn't know what the future held. So when I started speccing the new hardware for our data center, that knowledge combined with the fact that the benchmarking we were doing on the new AMD EPYC processors that we were benchmarking with Dell, we realized that the footprint of the new installation would be a lot smaller. The energy consumption of the new installation would be a lot smaller, and the ability of our engineers to be able to perform their jobs remotely, all those elements fell together, and I decided to start looking at remote locating it rather than in our data center in our aging office block. So I contacted someone I knew from previous conversations with Verne Global, and we started to piece the puzzle together and ended up with really a remarkably efficient system, productivity wise and operationally, as well as energy.
Okay, now Verne Global, of course, is a Dell Technologies titanium partner. It's
Yep.
also an HPC as a service provider. Tell us about Verne's HPC class capabilities that Wirth utilizes.
So our hardware that's located at Verne Global is exclusively ours and our design. We designed the installation with Dell. So in terms of Verne Global's HPC as a service offering, we're not currently tapping into that, but their knowledge of how to host the kit and how to look after it and the infrastructure, connectivity to it, and security, not just security in terms of cybersecurity, but knowing that the power is always going to be on and there's not going to be any power cuts and so on. All of that comes to making it an ideal place for us to host the kit. But it also means that if through growth we get to a point where we're needing to burst out and use more HPC capacity than we currently have on our chunk of kit, we know that we could burst out onto their HPC as a service.
So it's almost a private cloud kind of capability there. Have you all measured the energy savings that have been realized by going to Verne with this geothermal-powered data center?
Yeah. So our new hardware, which replaces all of our Windows infrastructure, email, servers, and so on. All our desktop computers have been virtualized on it, as well as our HPC cluster and data storage. All of that new kit is using about, I think it's 25% of the electricity that our old infrastructure used. So that would be the case whether it was located in Iceland or in Bicester, UK. But then that remaining 25% that we're still using is 100% renewable. So not only have we reduced the number of kilowatt hours we're using, but it's all carbon zero.
And share with us a little bit about some of the Dell hardware you're using.
Yeah, so we've got a primarily based on Dell PowerEdge servers with AMD EPYC second generation processors. The HPC cluster, the previous cluster we had was split over 4 racks, I think, and the new kit has been compressed right down into 1 rack. It's made up of 18 servers with 64 cores in each. And then we've got, I think it's 300 terabytes of data storage all hooked onto that with InfiniBand networks. That's in one setup, and then we've got virtualized desktops and workstations that our engineers can log into from home. So, for example, some of the work we do requires very heavy graphics and very large memory on your workstation. And our engineers, just with a laptop at home, VPN into the servers in Iceland, fire up a virtualized machine that might have 200 gig of memory in it, and a slice of a NVIDIA Tesla 4 T4, and they're operating a machine that's as powerful as, or more powerful than one that would be sat next to them making a racket.
Okay. And tell us about the energy efficiency gains Wirth has delivered for some clients, maybe on an anecdotal basis, quantifiable reductions in carbon footprints.
So on the refrigeration side, our background being from motorsport, we were used to going wind tunnel testing and track testing, and then proving our designs on the track, ultimately in a race. So we carried that correlation and validation process through into work we now do, which means that when we say, oh, our product, if you clip it onto the front of your fridge, it tidies up the airflow and it will give you this saving. That's not just a rough estimate of the saving. It's something that's been tested and proven out in multiple multi-month trials in store and in test lab conditions. So our retrofit EcoBlade package that can be attached onto the front of shelves in supermarkets, that saves 20% to 25% of the electricity consumption of the refrigeration pack. In real terms, what that means is that for a typical 4-foot wide chunk of a fridge, so a typical supermarket shelf is about 4 foot wide. For that piece, we are saving about 1,000 kilowatt hours of electricity per year. So over a medium-sized store that might have 200 foot of open-fronted refrigerated display case or cabinet, you're looking at about 50,000 kilowatt hours saved per year, which is
okay. Yeah, tremendous work.
Yeah,
great stuff. Well, Rob, it's been a pleasure speaking with you today. We've been with Rob Rowsell at Wirth Research. Thanks so much for spending some time with us.
Thank you very much.